The next service that we're going to take a look at is the Simple Storage Service, otherwise known as S3. S3 was one of the very first services launched by AWS back in 2005. S3 is basically a storage service. It's a way to securely store highly durable objects within AWS. What's an object? Well, an object is a sort of a fancy way of saying a file, but it's a data file that it has more than just data. It has some metadata associated with it. So S3 is essentially a key value store where the key is the name of the file and the value is the data and the metadata associated with the file. So every file and every object within S3 will have a key. It'll have its value, which is the data. It'll have some version information describing the version of the file. And it might have a whole set of metadata that you can customize and associate with that particular file. So think of S3 as a way to store individual files as objects within AWS. The data that you store within S3 is highly durable. What does that mean? Well, durability means that it's highly unlikely that a file is going to become corrupted or a file will go missing. It will be sort of like inadvertently deleted by AWS. And the level of durability they offer is what they call 11 nines. So it's 99.9999999. I can't even say how many nines there, but 99 and then followed by 9 nines. So it's 11 durability. So it's something like on the order of like 1 in billions of files might experience some data corruption within AWS. And it's highly resilient. So your data isn't just stored in one availability zone within a particular region. Your data is actually stored across multiple regions, typically or multiple availability zones. So typically at least 3 availability zones within that region. That way, if one of the availability zones experienced a problem, you'd still be able to access your data in the other 2 availability zones. This has some interesting implications for data consistency, which we'll address here shortly. The S3 service is highly available, meaning that when you need to access your data in S3, it's highly likely that you'll be able to do so. They offer 4 nines of availability, meaning that the S3 service is going to be available at least 99.99% of the time. And you're given an unlimited amount of storage within S3. You can store as little or as much data in S3 as you'd like. The individual files that you upload into S3 can be as small as 0 bytes. You might be asking, well, what do you mean a 0 byte file? That's kind of weird, which it is. I don't know of a use case where you would store a 0 byte file, but you could do it because remember, this is sort of a key value store. You could think of it as like almost like a database in some ways, where you're storing an object and the value is the data. In this case, you could store an object that has no data in it. And you can store files up to, at least the time of this video, up to 5 terabytes inside. So fairly large files you can store in the S3 service. One of the key things to understand about S3 is that S3 is not a file system. It's not like the NTFS file system on your Windows machine or the ext4 file system on a Linux server. those are file systems with with directories and file permissions and so on. And those files are accessed by your applications and services running on your local machine. S3 isn't like that. S3 is an internet accessible object store. It's not a file system. You can't use it to store your MySQL database. You can't use it to you can't use it with traditional applications that are designed to work with a typical standardized file system. S3 works very differently. So how do you work with S3? Well, the first important thing to understand is that the S3 storage namespace is partitioned into things that we call buckets. So you can have S3 buckets that you define within each region of AWS. You create a bucket, and the bucket is the namespace, is the area in which you would actually store your files. And when you define the name for your bucket in a particular region, the important thing to understand is that bucket name actually has to be unique globally. And you'll see why here in a bit. But long story short, essentially, the S3 bucket has got an internet URL, and that internet URL must be unique. So AWS, when you try to create a new bucket, they will only allow you to use a bucket name which nobody else in the world has already used. That must be unique. Initially, you can create up to 100 buckets in your account, but that's a limit that you will be able to increase if you need to. What you'll find is that AWS applies limits to the amount of resources that you can create, especially as a new customer. And as you get close to exceeding limits, or when you exceed limits, then you can reach out to AWS via their support system and request that the account limits be increased so that you can use more resources. And this is a process that I and my team members have done literally hundreds of times as we use more and more resources within AWS. And usually the process of requesting and more resources is something that's done very quickly. I mentioned earlier that the objects you upload into S3 are actually stored in multiple availability zones within a region. And this might have some interesting data consistency implications. Well, so what this means is that when you create new objects and you upload a new file into your S3 bucket, that file is then written to multiple availability zones within the region that bucket is located. When you write that file, you can immediately read the contents of that object right after it's been written. And that's what we call read after write consistency. Whatever you write can be read immediately, and the data that you read is the same as the data that you wrote when you created the object. Kind of makes sense. Where things get a little sketchy is when you try to update or delete objects within S3. When you update or delete objects in S3, then you encounter what we call eventual consistency. So it's possible that when you update an object in S3, and if you try to immediately read the contents of that object right after you updated it, it's possible that you might read the contents of the old version of the object. Because think about it, when you're updating the object, it's got to update the contents in 3 different data center locations and 3 different availability zones. And so it's possible that you might update the object and try to read it again before AWS, before S3 has an opportunity to update that object in every single availability zone. And you might be thinking, well, that kind of sucks. I mean, that could present some problems from an application design perspective. And you're absolutely right. From a software development perspective, this is something that's really important to keep in mind. This notion that if you update or delete objects in S3, you've got to keep in mind that you're dealing with a service that is eventually consistent, and your application has to be specifically designed to potentially handle that scenario. From a security perspective, S3 is highly secure. When you're transmitting data, you're creating a new object in an S3 bucket and uploading your file, that data transmission happens over a secured SSL TLS connection, so it's securely transmitted to AWS. You can set up access control policies on a per bucket or per file level. In other words, you can specify who is allowed to upload objects into an S3 bucket. You can specify what types of objects are allowed to be created within a bucket. You can define encryption at rest for data within S3. Encryption at rest means that when the data is actually written and stored on the Amazon S3 hard drives or SSD drives, that the data is going to be encrypted when it's written on that persistent storage. That way, if some rogue AWS employee were to come along and steal hard drives or something and take them home, they wouldn't actually be able to read the data that you've written to those disks, because the data would have been encrypted at rest. It would have been encrypted when it was written to the actual disk. You can set up audit logs to track all the different access to your S3 buckets and to the objects, the files that are stored in those S3 buckets. From a cost perspective, there are a couple different cost components. First of all, you're going to pay for the amount of storage space that you consume on a per gigabyte basis. And those prices can vary based upon the region, and generally they get just cheaper and cheaper over time. But at the time of this video, it's about 10 cents per month per gigabyte of data that's being stored in S3. You are also going to pay for the number of requests for data within your S3 bucket. And this can generally be sort of like a minimal cost, unless you have like a incredibly popular application that's serving millions and millions of requests from your S3 bucket. Then those costs might begin to add up. But essentially, you're paying for the underlying sort of compute capacity that's required to support the delivery of your S3 objects. And finally, you might pay for data transmission, for data bandwidth in certain cases. It doesn't cost you anything to upload data and upload files into S3, but you will pay if you need to download those files. If you're going to download them to your home, then you're going to pay internet bandwidth charges, and not just for your internet service provider, but you'll pay as part of your AWS account. There's a fee for downloading that data, and again, it's small, but depending on the volume, it can definitely add up over time. And there are a couple other additional S3 features that I want to mention in this course. We won't really use them that often, but these are features that I want you to at least be aware of. You can specify different storage classes for your S3, and we'll look at those here shortly. So there are certain use cases where you might want highly resilient, really fast storage, and there might be other cases where you're like, hey, I don't need my storage to be so resilient or so fast, and so I just want really cheap storage. You can set up lifecycle management in S3 to automate some of your data lifecycle management tasks. For example, you might have a corporate policy which says that any data that's uploaded to a particular S3 bucket has to be deleted after 5 years. And so instead of having somebody manually go into the S3 bucket, constantly and try to figure out which objects are older than 5 years and then manually delete them, you can automate the entire life cycle of these objects and set up a lifecycle management policy to automatically delete objects that are older than 5 years. And then finally, you can set up versioning as well within your S3 bucket. And versioning allows you to keep track of multiple versions of your files. So as you update files over time, there might be cases where you want to track the different changes, to track the different versions of your files. You might want to have the ability to revert back to an older version of a file. And S3 can provide that versioning for you automatically. I mentioned that S3 makes available a number of different storage classes to you. And you can use these storage classes to support different scenarios in your organization. When you create a new S3 bucket and you start uploading objects into it, generally you're using the standard S3 storage class. And that was the one that I mentioned earlier that has 11 nines of durability, and it's available 99.99% of the time. It might be the case where you're storing data in an S3 bucket, but that data isn't accessed all that frequently. Maybe you upload a bunch of data, but it's only accessed like a handful of times a month. Well, in that case, you might not care so much about the availability of the service. Maybe if the service is available just 99.9% of the time, that would be good enough because the data just isn't accessed all that frequently. So you're willing to sacrifice some availability for lower cost. And so you can pay less if you select the infrequently accessed storage class. And then, beyond that, you might have data which not only isn't accessed very frequently, but it's data that, it doesn't have, the service really doesn't need to be resilient at all. In other words, this is sort of like scratch data. If you need to access it immediately when you need to access it, which isn't very frequently. But if you were to lose the data, that's not the end of the world. It's not such a big deal because you could probably recreate it really easily. So something like if you're creating a thumbnail from a set of images or something, the thumbnail, if you lost it, you could easily recreate it if you needed to. And because of that, you can use the one of the cheapest storage tiers, which is the infrequently accessed one zone tier, which means that your data is stored in one availability zone and the service will be available 99.5% of the time. You might have data that starts out in the standard tier, but then over time, you find that it's being infrequently accessed, and it would make more sense to move that data to the infrequently accessed storage class. But having to make those decisions manually would be really time consuming and painful. So what AWS offers to us is an intelligent tiering service, which will actually monitor our S3 objects and automatically move them from the standard storage class to the infrequently accessed storage class, depending on the access patterns for those objects. And so it'll kind of move them between those two different storage classes automatically for us. And the big benefit is that that saves us money. We're not paying for access levels that we don't actually need. And there's two other S3 storage classes I wanted to mention here as well. There's a service called Glacier, which we use for long-term data archiving. It's a way to archive our data. Think of this as being sort of like the tape backup option for S3. If we want to store our data in like the cheapest possible storage, we would put it into Glacier. Now, the objects that we store in Glacier are not immediately accessible. So unlike these other S3 tiers where we can immediately access our data, we can't access it immediately within Glacier. We have to make a request to restore that data from Glacier into our S3 bucket. And that might take several minutes, and it might take several hours. We can kind of configure that. The faster we want the data, the more we would have to pay to get that data restored. But Glacier is basically the backup service. If we want to store data for really long periods of time, like 7 or more years, then we can use the Deep Glacier service, which is even cheaper than Glacier. And the biggest limitation with the Deep Glacier service is that the data might take up to 12 hours to retrieve for us. So Deep Glacier would be designed for something like compliance purposes. If we had to store data on every transaction in our system and had to store those transactions for 7 to 12 years or something, then the chances are we would never be reading these data transactions or accessing them, maybe only for legal discovery purposes. We would put them into Deep Glacier because that's the cheapest place to put that data for long-term storage.